So the periodic table of elements is this, okay? It is a grouping of the different elements of matter. If you guys go back to our old definition of element, an element is the smallest piece of a kind of matter that has the same properties. They're actually arranged by their properties on this table, okay? Hydrogen is the lightest, helium is next, and then lithium, and then beryllium, and so on. So they just count and get higher and higher and higher. And you'll notice the numbers get higher. Yeah, pull this up and use this. The numbers get higher, okay? These numbers are the number of protons in the atom. Hydrogen has 1, and helium has 2, lithium 3, beryllium 4, and so on. But the atoms are actually also arranged not only in a list, but you'll notice that they're in different rows. And there's a reasoning for that that we're going to come to understand as well. Okay. But we can tell more about an atom than just how many protons it has, more than just this atomic number. The atomic number tells us how many of these red particles, or they're red in this Bohr model here, how many of these red particles are in an atom. Here we see, well, we can see 4 of them, but we can imagine that it's like a 3D model. So we can imagine that there are 3 more back behind there. Okay. So nitrogen has 7 protons. That's why it's element number 7. Okay. We can say that its atomic number is 7. Okay. The number of protons is what we're counting here. Okay. Nitrogen always has 7. Okay. Carbon always has 6. Hydrogen always has 1. Okay. Sodium always has 11. Magnesium always has 12. There are different numbers of neutrons in each atom. Nitrogen might have extra neutrons, and its atomic number would still be 7. Okay. So we had this quick self-check, and it said how many protons are in an atom of boron, and how many protons are in an atom of fluorine. And so we just go to our P table here, boron. So here's boron. We look, and it has 5. There's a number 5 here at the top. Okay, so our answer to that one is 5. Fluorine is this element right here. Okay, we'll notice that there are 2 different numbers on this element card. I call these element cards. But 9 is the one we're looking for. This is the number of protons. This is the atomic number. Cool. So now we know what an atomic number is. It's the small number on the element card. That's an easy way to look at it. It's the small number. It's the lowest number on an element card. Now, some element cards have ionization states and things like that, but I'm not going to give you those. So the smallest number on an element card is the atomic number. But there's something else about an atom, about an element, that we can tell. We can talk about the atomic mass of an element. Okay. Nitrogen has an atomic mass of, well, a little more than 14. Okay. And so there's a way that we get this a little more than 14. Okay. This is the average atomic mass of nitrogen. If you pick an atom of nitrogen out of the air, okay, and you measured it somehow, a single atom, you would find that nitrogen probably had a mass of exactly 14. Okay, that is 14 protons and neutrons. Okay, 14 protons and neutrons in nitrogen. But 7 times out of every 1,000, 7 out of every 1,000 nitrogen atoms might have an extra neutron. And so that's what this little decimal point here is. That's where that factors in on this average. Okay. If you take 1,000 nitrogen atoms and you weigh them, you would find that 7 of them have a mass of 15. Okay. And that's just the way it is. 7 of them would have an extra neutron. So the atomic mass is the protons and the neutrons. Remember, for our purposes, electrons weigh nothing. Okay, They've been measured to have mass, but in high school chemistry, we pretend that that's not true. It helps us build our understandings up. Okay. On the periodic table and on element cards, the atomic mass is usually at the bottom. Okay, sometimes they put it at the top and they put the atomic number at the bottom. I like a periodic table to have the mass at the bottom. All you need to know is it's the largest number on the element card. Okay, for nitrogen, it's 14.007. And when I ask you what is the atomic mass of nitrogen, you're going to want to round that. Okay, you want to take that to the nearest whole number. So the atomic mass of nitrogen is about 14. In high school chemistry, in high school physical science, I should say, we're not going to deal with measuring things to this decimal when we're talking about the mass of atoms. It just wouldn't be appropriate. We will see where that comes from, though. Now, I want to show you guys this video really quickly. I need to fix the sound here. I'll show you guys this YouTube video of Ricochet Science and how they talk about atomic mass. So I need to pause my recording really quickly. Okay, so I will link to that video in my recording on the Google Classroom assignment. I don't want to rip off someone else's video and put it inside my own here. So to find the atomic mass, we take the neutrons and we add it to the protons. So we take the 7 neutrons that are usually in nitrogen and we add it to the 7 that are listed here, and that gives us the mass. Okay. So quick questions here. What is the atomic mass of beryllium? What is the atomic mass of neon? So the atomic mass of beryllium is 9.0122. Okay. You can see that here. I'm just going to call this 9.01. I'm happy with that. I'm never going to get too specific with decimal places. It takes something that's pretty simple to understand and makes it more confusing, at least for right now. The atomic mass of neon. So we're going to go on the periodic table. That's not the periodic table. We're going to the periodic table, and we're going to find the atomic mass of neon. Now, I know right where these are. I know that for you guys, it takes some searching, and that's okay. Looking over this and studying this and knowing where things are is not a bad thing, because it's going to help us with our understandings later. But neon's right here, and it has a mass of 20.180. We'll call it 20.18. That means that if I grab one neon atom, chances are it has 20 protons and neutrons. But 18 times out of every 100, okay, if I have 100 neon atoms, 18 of those are going to have an extra neutron. That's just what this is. That's just what this averages mean. Okay, this is the average atomic mass. So to review, and I know that I'm really hammering on this, but the atomic mass is the number of neutrons plus the number of protons. So if the mass is, neutrons equals, to find the number of neutrons, we're just going to take the atomic mass, subtract the atomic number, and that'll tell us the number of neutrons. So nitrogen has an atomic mass of 14. We'll call that 14 because we can round. Okay. We subtract the 7 protons that we know are there, and that tells us that on average nitrogen has about 7 neutrons. Okay. 14 minus 7 equals 7. And we can do this for all of the elements. Go to the periodic table. If I want to know the number of protons, if I want to know the number of neutrons there are in oxygen, I can look. I can say, well, oxygen has a mass of Well, let's call this 16, right? That's close enough to 16. Oxygen has 16 protons and neutrons. 8 of those are protons. So 16 minus 8 is 8. Now, the reason why we have that decimal point, the reason we have this decimal point here is because of isotopes. Atoms sometimes have an unusual number of neutrons. Okay, sometimes they have an unusual number of neutrons. So we just talked about carbon. Carbon usually has 6 protons. I'm sorry. Carbon always has 6 protons. Carbon usually has 6 neutrons to go with that. But 11 times out of 1,000, it has an extra one. Okay. Actually, 10 times out of 1,000, it has an extra one. And 1 time out of 1,000, it has 2 extras. And that's where we get this mass. Okay, that's where this average number comes from. Sometimes carbon has extra neutrons. Now, if you go back to when we did the build an atom simulation, we realized that having extra neutrons will make an atom unstable. And that's absolutely true. Okay, that's absolutely true. If carbon had 9 neutrons, well, then carbon would be really radioactive. Okay, it would be dangerous to be around. And actually, with 8 neutrons, it's pretty radioactive. That atom will fall apart. Those neutrons will fall off of that carbon. And when those neutrons fall off of carbon and they hit you, that is radiation. Carbon always has 6 protons, but sometimes it has some extra neutrons. And eventually, those will fall off. They will come apart. So how many protons and neutrons does carbon have? Well, we can look on the periodic table here, okay? It has a mass of 12, so usually 12. Usually 12. Sometimes, we should say rarely, 13 or 14. 6 of these are always protons, because if carbon had extra protons, it wouldn't be carbon. Question 6 asks us, how do we find the number of neutrons? That's easy. We take the mass minus the atomic number, or the number of protons. So how many neutrons does a usual atom of helium have? We'll take a look. Here's helium. It has an atomic mass of, we can call this 4, right? We can all agree that we're going to round that to 4. Don't get confused in the rounding. It's usually the nearest number. Like lithium, that's 7. Beryllium, though, that's 9. Okay. So for helium, it has a mass of 4. 2 of those are protons. So 2 of those are neutrons. Mass 4 minus 2 protons equals 2 neutrons. Okay, so what we know about atoms is the role that neutrons have is they let the protons be around each other. Okay, they keep atoms stable, but if there are too many, then it's unstable. And they're part of what gives atoms mass. Okay, that's what we need to know about neutrons. Now, this is an activity that you will certainly see on the test in some form. We're going to look up, we're going to reference our periodic table, and we're going to find the symbol, the atomic number, the number of protons, and the atomic mass of each of these elements. We'll start with boron. Okay. Boron has a symbol of B, and it has an atomic number. I don't know. I don't know. So I need to go on my periodic table and find it. Boron, 5. Okay, it has an atomic number of 5. There it is. But you know what? I already knew that because the atomic number and the protons are always going to be the same thing. The atomic number is simply the number of protons. Next, we'll go to the atomic mass of boron. Look at boron. Boron has a mass of 10.81. So we're going to have to round that, right? 10.81, that's going to round up to 11. Usually boron has 11. And look, I already gave you that information in this table. We didn't even really need to use this. Next, we go to oxygen. Oxygen has a symbol. We should go look up what that is. It's O. Oxygen has a symbol O. Oxygen has, I'll bet it has 8 protons because its atomic number is 8. So I'll bet it has 8 protons. Yep. Okay. And if it has 8 neutrons, then its atomic mass is 16. Okay. Sodium. Sodium has a weird name, and on the test I might ask you to sort of look this up. If I send you looking for sodium, you can't look for SO. Okay, you got to go and look for Na. Okay, that goes back to those Latin names for different elements that we've talked about. Okay, so sodium is Na, and it has, it's right here, it has a mass, an average atomic mass of 22.99, and so its real atomic mass is going to be 23. Okay. Copper, again, has a weird symbol. It's not CO like you might expect. Okay. Here we're going to have to calculate. We're going to have to find the number of neutrons. So I have 63 minus 29. I take the total number of protons and neutrons. I subtract the 29 of that, which is protons, and that gives me, let me do some calculator work here. 63 minus 29. I'm a great mathematician. 34. So usually copper has about 34 neutrons. You'll notice that's 5 more than it has protons. Okay. As you go down the periodic table, you'll notice that atoms tend to like having more neutrons around. At the same time, though, those atoms are less and less stable. We're not really going to get into that, but it's the truth. Okay, so hopefully we can find, well, I should start over. Hopefully we can define the atomic number and find it on the periodic table. We can find it for each element. Hopefully we can find the atomic mass on the periodic table for each element. Hopefully we know that the atomic mass is really an average. Okay. Hopefully we can find, it's an average because there are isotopes. There are weird atoms with extra neutrons or less neutrons or something. Hopefully we can find the number of protons and neutrons in any element.